Chapter 6. Algebraic expressions. Expression means modes of representation. In our daily life, we come across patterns and formulae which solves our problems. These patterns or formulae can be generalized to suit many situations. Let us see some examples. 1. We had gone to market to buy chocolate. The cost of a chocolate is rupees 25.00, cost of 2 chocolate is rupees 50.00, cost of 3 chocolate are rupees 75.00, and so on. Now if we want to buy more chocolate, how to find out the cost? Cost of 1 chocolate is equal to 1 multiply rupees 25 is equal to rupees 25. Cost of 2 chocolate is equal to 2 multiply rupees 25 is equal to rupees 50. Cost of 3 chocolate is equal to 3 multiply rupees 25 is equal to rupees 75. So we have seen the cost of chocolate multiply rupees 25. Now if we want to buy some chocolate, let us say the number is y. So cost of y number of chocolate is equal to y multiply rupees 25. This mode of representation is generalization to solve the problem. This is called algebraic expression. 2. There is a series of numbers 5, 10, 15, 20, 25. Here we have seen the first term is 5, that is 1 multiply 5, where 1 is the number of term. Second term will be 2 multiply 5. Third term will be 3 multiply 5. And so on. Now if we try to find out what would be the nth term, we use a generalized formula for nth term n multiply 5. Now if we try to find out the successor or predecessor of any term, how to find out? Observation. The third of the series is 15. Let us try to find out the successor and predecessor of number. 15 successor of 15 is 20, or we can say 3 multiply 5 plus 5, where 3 is the number of term. Predecessor of 15 is 10, or we can say the predecessor is 3 multiply 5 minus 5 is equal to 10, where 3 is the number of term. Similarly, if we try to find out the predecessor and successor of nth term, we can say nth term is equal to n multiply 5. Successor of nth term is equal to n multiply 5 plus 5. Predecessor of nth term is equal to n multiply 5 minus 5. These are the generalized formula or algebraic expressions which helps to solve many problems. Algebraic expressions. An algebraic expression is formed with variables and constants. Variable, a quantity which can take different numerical values. It is generally represented by small English alphabet like A, B, C, N, X, Y, etc. Its value is not fixed. Constant. It has a fixed value like 2, 4, 6, 8, 10, etc. Algebraic expression, a combination of constants and variables connected by fundamental operations, that is plus, minus, multiply, divided by. Example, minus 4x plus 6, 6y minus 7, 7n plus 8, etc. Terms of expression. A constant, a variable or a combination of constant and variable connected with any fundamental operation is called a term. Examples, 1 5x plus 6y has two terms 5x and 6y. 2 7xy minus 8yz has two terms 7xy and 8yz. 3. 4x raised to the power to minus 8xy plus 9yz has three terms: 4x raised to the power to 8xy and 9yz. Factor S of term. An algebraic expression 5p raised to the power to minus 6pq plus 7q raised to the power 2 has three terms: 5p raised to the power 2, 6pq and 7q raised to the power 2. The term 5p raised to the power 2 is the product of 5 multiply p multiply p. The term 6pq is the product of 6 multiply p multiply q. The term 7q raised to the power 2 is the product of 7 multiply q multiply q. So the factors of term 5p raised to the power 2. 5p, p. The factors of term 6pq. 6pq. The factors of term 7q2. 7q. We can draw a diagram to understand the factors of a term to understand clearly. 5p raised to the power to minus 6pq plus 7q raised to the power 2, algebraic expression. Term 5p raised to the power 2. Term 6pq. Term 7q raised to the power 2. 5. P. P. Factors of term 6. P. Q. Factors of term 7. Q. Q. Factors of term coefficients. The terms are product of factors. One of the factors may be numerical and the others may be algebraic or variables. Let us take terms 5xy raised to the power 2 and minus 7xy. 5xy raised to the power 2 minus 7xy. 5 is coefficient of xy raised to the power 2. Coefficient of x minus 7y. X is coefficient of 5y raised to the power 2. Coefficient of y minus 7x. Y is coefficient of 5xy. Coefficient of 7 minus xy. 5y is coefficient of xy. 5x is coefficient of y raised to the power 2. Therefore, in a term of algebraic expression, any of the factors along with the sign of term is called coefficient of remaining factors. Like and unlike terms. Like term, terms of algebraic expression having same algebraic functions are called like terms, or in other words we can say that all terms containing same literal numbers with same exponents are called like terms. Example, a, 4 and 9a contain the variable a, so they are like terms. To a raised to the power to b, 4b a raised to the power 2 contain the variables a raised to the power to b, so they are like terms. Unlike terms, terms having different algebraic functions are called unlike terms. Example, 2x raised to the power 2y, 7xy raised to the power 2, 5x 9y 2xy. Here the algebraic functions are different, so they are unlike terms. Kinds of algebraic expressions. Algebraic expressions are classified according to number of terms they have. Monomial, an algebraic expression which contains only one term, is called monomial. Example, 5x raised to the power 2y, 45x 27xy 10, etc. Binomial, an algebraic expression containing two terms, is called binomial. Example, 5x raised to the power 2y plus 7y minus 5x plus 7, 2x raised to the power 2 plus 4y raised to the power 2, etc. Trinomial, an algebraic expression containing three terms, is called trinomial. Example, 5x raised to the power 2 plus 7xy plus 9y raised to the power 2 minus 4x plus 6y plus 72, 6x raised to the power 3 minus 4x raised to the power 2y plus 11y raised to the power 3, etc. Polynomials, an expression which contains two or more than two terms is called a polynomial. Thus binomial, trinomial are also a polynomial. Example, minus 2x raised to the power 2 plus 3y raised to the power 2 plus 4xy plus 9. 3x raised to the power 3 minus 4y raised to the power 2 plus 5x raised to the power 2y minus 4xy raised to the power 3. Degree of an algebraic expression. The expressions 4a or 9b are monomials. The expression 7a plus 10b is a binomial since it has two terms. The expression 9a plus 5b plus 3c is a trinomial since it has three terms. The expression 5a plus 2b plus 7c plus 8d is a polynomial since it has more than two terms. All the above expressions are of first degree, and in these expressions the variables, unknown terms, do not have any power index. All of them are raised to the power of 1. Now let us consider an algebraic expression. 3a raised to the power 2 plus 2a minus 18. It is trinomial since it has three terms. In term 3a raised to the power 2, the power of variable a is 2. In term 2a, the power of variable a is 1. The term minus 18 is a constant not variable, therefore the power is 0. The highest power of the variable in the expression is 2. Hence the degree of algebraic expression is 2. 4x raised to the power 4 plus 5x raised to the power 2 minus 6x plus 20. This is a polynomial. The highest power of the variable x is 4. So the degree of the algebraic expression is 4. 5y raised to the power 5. This is a monomial. The highest power of the variable y is 5. So the degree of the algebraic expressions is 5. Therefore we can say that the degree of an algebraic expression is the highest power of the variable in that expression. Now let us consider two variables a and b. Consider the polynomial a raised to the power 6 plus a raised to the power 3b raised to the power 4 plus 3 a raised to the power 2 plus 4b raised to the power 2 plus 9. When the variables are multiplied, their powers are added. It decides the degree of the expression. The power of variable of term a raised to the power 6 is 6. The power of variable of term a raised to the power 3b raised to the power 4 is 7. The power of variable of term 3 a raised to the power 2 is 2. The power of variable of term 4b raised to the power 2 is 2. The power of variable of term 9 is 0. The highest power of the variables in the given expression is 7. So the degree of algebraic expression a raised to the power 6 plus a raised to the power 3b raised to the power 4 plus 3 a raised to the power 2 plus 4b raised to the power 2 plus 9 is 7. Example 1. Find the degree of the algebraic expression 6a4 plus a2b 3 plus b3 plus a plus 5. Solution. The polynomials are usually written in the descending order of powers of their terms. So after rearranging we get the expression 6 a raised to the power 4 plus a raised to the power to be raised to the power 3 plus b raised to the power 3 plus a plus 5. The power of variable of term 6 a raised to the power 4 is 4. The power of variable of term a raised to the power to be raised to the power 3 is 5. The power of variable of term b raised to the power 3 is 3. The power of variable of term a, b is 2. The power of variable of term 5 is 0. So, the highest power of variables is 5. Therefore, degree of algebraic expression is 5. To find the value of an algebraic expression. Example, find the value of 5x raised to the power 2y plus 7 times 2 plus 2xy plus 7, when x is equal to 3 and y is equal to 2. Solution, after substituting 3 for x and 2 for y, we get 5x raised to the power 2y plus 7x raised to the power 2 plus 2xy plus 7. 5, 3, raised to the power 2. 2 plus 7, 3, raised to the power 2. Plus 2, 3, 2 plus 7. Is equal to 5 multiply 9 multiply 2 plus 7 multiply 9 plus 12 plus 7. Is equal to 90 plus 63 plus 12 plus 7. Is equal to 172. Addition of algebraic expressions. We can add to quantities if they have same units or like terms. The units which are not same or the terms which not like terms cannot be added. So to add like terms, follow the steps as mentioned below. 1. Obtain all like terms. 2. Add all the numerical coefficient of like terms. 3. There are two methods of addition. A. Horizontal method. B. Column method. A. Horizontal method. In this method we bring all like terms together in a horizontal line and then we add. Example 1. Find the sum of 5x 7x minus 4x and minus 3x. Solution, 5x plus 7x minus 4x minus 3x is equal to 5x. B. Column method. We first arrange the like terms in columns and then add. Example 1. Find the sum of 2x plus 7y minus 9z 7x minus 2y plus 5z and 3x plus 4y plus 5z. Solution. Write all the like terms in a column and then add vertically, that is x under x, y under y and z under z. 2x plus 7y minus 9z. 7x minus 2y plus 5z. 3x plus 4y plus 5z. Upon 12x plus 9y plus z. Subtraction of algebraic expressions. Like addition, subtraction also follows the same rule, that is subtraction is possible between two like terms. When we subtract a number from another number, we add the additive inverse of subtrahend to the minuend. Example 1. Subtract 8 from 12. Solution. Subtract 8 means we add additive inverse of 8 to 12. Additive inverse of 8 is minus 8. So, 12 minus 8 is equal to 4. Subtraction can be done either in column or horizontally by combining the like terms after changing the sign of the terms to be subtracted.